All right, well, let's go ahead and dive into our lesson for today. All right, so yesterday we were working on page 74, and let's go ahead and finish up number 12 and 13. Let's save number 12 for last. Let's go ahead and dive with number 13. All right, so as you can see here, with our very first term, I guess you can say, we have a -5 as our output there. And then as we continue to go down, we go -5, +25, -125, +625. So hopefully you're able to see that it's growing at an exponential rate. So I know that my base is going to have a 5 there, but you see how we go back and forth from negative to positive, negative to positive. So let's say that our base, and let's go ahead and do our recursive. So let's do f of n, that equals f of n minus 1. And then what's happening each time? As I increase, I'm multiplying by -5. So let's do, just so it's not confusing, let's say times -5 times -5 times -5. So my foundation is there, we're multiplying by -5 every single time. So if I want to go here and say f of n equals f of n minus 1 times -5, I could. Or if I wanted to look a little bit cleaner, let's rearrange it and have f of n and just put that -5 in the front. So let's say -5 times f of n minus 1. Okay, so let's go with that. Now keep in mind, once we have our recursive equation in place, we need to define the very first term that we were given. So you see this n at 1 right here. We need to also put f of n, switch it to f of 1, and what's the actual output for that? The actual output is -5. So let's say f of 1 is -5. Okay, so that's our recursive. Now let's look at our, let's do orange. All right, let's look at our explicit. So every time here, we're multiplying by -5. But you should also be able to see that this output here is like -5 to the first. This one is -5 to the second, -5 to the third, and this is -5 to the fourth. Hopefully you're able to see how these outputs correlate with that exponent changing. Well, if you look at the n, do you see how my exponent correlates with the step that we're on? So we have f of 1, and we're raising -5 to the first. We have f of 2, we're raising it to the second. F of 3 to the third, and then f of 4 to the fourth. So the pattern here is your actual exponent is the actual step that we're on. So this is pretty straightforward. Let's just call this, and let's write it down here, f, and we can still say f of n, but the output here, we want to represent that -5 being raised to that exponent. So each one of my exponents is going to be 1, 2, 3, 4. So whatever my input here is, and even though it says n, you can think of this as x and y. So let's say -5 to the x power. Okay, hope that makes sense. -5 to the x. This is your explicit equation. It's telling you exactly what you're doing there. Okay. All right, number 12 is slightly tricky for two reasons. Number one, I see that this number is actually going down, but then also, I'm not sure if you caught it or not, but the n actually starts on the number 2. Every other table that we've had, or every other function that we had, we started with the very first step. So that kind of makes it a little bit trickier, but we can still handle it. All right, so what's happening here? As we go one step at a time, what's happening to your output? It's decreasing. I see I went down 8 here, went down 4, went down 2. But if I think about multiplying or dividing, I can think, well, here I divide it by 2, divided by 2, divided by 2. So we can think divide by 2, or if you prefer to think of it like a fraction, you can say times, and then dividing by 2 is like saying times 1/2, times 1/2, times 1/2. So both of those work for that. But let's go ahead and just do our recursive. That one is a little bit easier because we have f of n, then we have f of n minus 1. And again, what's happening each time? We can put multiply. Let's do that. Let's say times 1/2. Okay, so you can put that down. Or if you prefer to have division, you can say all of that over 2, whichever one works best for you. I'm going to put times 1/2 just because I want to see it looking like that. And if you want to write it looking a little bit cleaner, then we can say 1/2 f n minus 1. All right, so that's the first part of my recursive. And then we also need to define the first term that we've given. So we can kind of look and say, well, if n at 2 was 16, 3 was 8, I can go back and say n at 1 was 32 maybe. But because we weren't given that in my table, let's not just assume that that is true, okay? So let's put down, instead of putting f of 1, let's put down f of 2, okay? So f at 2 gave me the output 16, okay? So we should have f of n equals 1/2 f parentheses n minus 1, and these are being multiplied unless you had it over 2, we're dividing, and then you have f of 2 equals 16. Okay, I think that's the easy part that everybody could easily see there. The next part is kind of tricky because of where we're starting at. We're starting at 16. So let's just dive right into the explicit. Let's just dive right into it. I see that I'm starting with 16, and it appears that we're multiplying by 1/2 each time, but we need to make sure that we take into consideration what our input is. So let me do this to get you started. Let's say f of n, and then let's start with 16 as our foundation, and we're multiplying it by 1/2. So let's say 16 times 1/2, and then whatever that number is raised to the x, raised to something power. I'm not going to give you the rest of it now. Press pause real quick and see if you can figure out what else you would put in your exponent here. So I have f of n equals 16 times 1/2 to the x, and then figure out something that will work here. Pause it real quick. All right, so from here, let's just go ahead and use 5. So if I put 5 in for x, let's see what the output is. So we have 16 times 1/2 to the 5 minus 1. Well, 5 minus 1 equals 4. What is 1/2 to the 4th power? Well, that's 1/2 times 1/2 times 1/2 times 1/2. So that would give me 1 over 2 times 2 is 4, times 2 is 8, times 2 is 16. So I have 1/16. So now I'm doing 16 times 1/16. And you guys know from those multiplicative inverses that this output is 1, but the output should have been 2. So the x minus 1 doesn't work. Let's try a different number. Instead of x minus 1, let's try x minus 2. All right, so x minus 2. So again, let's use that 5 again. So that would be 5. I'm going to go here. 16 times 1/2 to the 5 minus 2. Let's write that down. And 5 minus 2 is 3. So that's 1/2 to the 3rd power, which means 1/2 times 1/2 times 1/2, which gives me 2 times 2 is 4, times 2 is 8. So now I have 1/8. So let me get rid of this down here. 16 times 1/8. And that output, if I do my math, just go straight across, or you can cross reduce here. The output would be 2 here. Let's see what my output was in the table. Oh, the output was 2. So let's see if it works for the other one. Let's try it for 4. All right, so I'm going to erase this. And let's put in 4. So now I have, not 4. I still want this to be 2. I want this part to be 4. So 16 times 1/2 to the 4 minus 2. And let's see what happens there. 4 minus 2 is 2. So let's say 1/2 to the second power. And that gives me 1/4. Okay, so now let's do 16 times 1/4. And if I go straight across, you should be able to see that that gives me a total value of 4. So let's see if that matches up. Yes, 4 and 4. So that's my equation there. So let's use f of n equals 16 times 1/2 to the x minus 2. And before I forget, or before I just move on, let's make sure you guys understood what I was doing here. Keep in mind your order of operations. So I know it's tempting to say 16 times 1/2 and get 8 and then raise that to some power. But following your order of operations, we need to do parentheses first, then exponents, and then multiplying. So that's why we do this part first, and then you multiply, okay? All right, let's fast forward to our lesson 5. We're going to bypass page 75, 76, and 77, and let's dive into our ready, set, go. So looking at page 79, all right, this says fold a piece of paper, make a smooth crease. Open the paper and then examine the shape that you made. Is it a line? Of course it is. Will it always be a line? Of course it will. Justify your thinking. All right, so you guys know what a line is. They're just trying to build your understanding for what we call a straight angle. And you guys have seen this before. A straight angle is essentially just a straight line, okay? But the magic number for the degrees in a straight angle is always 180 degrees. Okay, it's always 180. And if you want to use this circle to justify that, you know your magic number for an entire circle is 360. So if I travel this much, I've traveled half the way. Well, that gives me, well, how much? What's half of 360? 180. So that's 180. And then if I go this much, that's 180. And if you look at this line that we made in the middle here, it says this should be a perpendicular bisector, which means both of these are right angles. It cuts all of this in half. And if all of this is 180, then you know that each one of these has to be 90. Like there's no way around it. So both of those have to be 90. All right, so let's fast forward. The second part of number 3, these are examples of linear pairs. And linear pairs, when you look at it, the word linear has the root word line in it. So linear pairs are just angles that combine together to make a straight line. So all of this angle plus this angle, straight line. This angle plus this angle, straight line. And then these two angles put together, straight line. All right, so what you really need to remember is that a straight line is 180, and if you go all the way around, it's 160. So look at number 4 on your next page. Number 4, if you know that all of this is 180, then to set up your equation, and I know you already know this, but let's set it up. Question mark plus 60 equals 180. If I ask you to solve that, you subtract 60 from 180, and you get that this equals 120. Number 5, that same thing. 35 plus question mark equals 180. And we're not going to do this every single time because you guys know, or you should see, that we're just subtracting these numbers from 180. So let's go ahead and do our math here. Minus 35 minus 35. We're left with question mark, which is some unknown number. Question mark equals 5, 4, 1. So the measure of that angle is 145 degrees. Okay? And I think you guys can see it. We're just subtracting from 180. So this would be 90. For this one, 180 minus 155 is what? 25? 25 degrees. All right. Now for this next part, 8 through 13, let's go ahead and actually continue to write out our equation, and then let's solve for not only the missing angle, but then also find the value of x. So these two, it's a linear pair, makes a straight angle. So all of that combined together, the 2x minus 1 plus the 47, all combines together to make 180. Okay, so if I bring those, let's bring that closer together so you can see it. If I bring all of this together, 2x minus 1 plus 47 equals 180, combine like terms, and you guys understand how to do that. Negative 1 plus 47, well, that's 46, right? So now you have 2x plus 46. To solve that, let's subtract 46. And again, I encourage you, if you need to press pause and you want to do it by yourself, go ahead and do that. Bring this straight down. You're left with 2x. That cancels out. Let's do orange here. 4, 3, 1. So 2x equals 134. So if I solve for x divided by 2, we're left with x equals, let's see, half of that is 2. What's that, 67? Let's go with 67, see what happens. All right, really good job there. And I'm sure you guys can see it. So set this up. 4x plus 12 plus 108 equals 180. That's your equation for number 9. For this one, 97 plus 8x plus 3 equals 180. That's your equation for that. And then for this one, 5x minus 40 plus 20 equals 180. That's your equation for that. All right, so going back to that very first one, we solved for x. We solved for what the value of x was, but let's also go back and dive deep into it and figure out the value of the missing angle. Now you can do it one of two ways. You could take this 67, plug it back into 2x minus 1 and see what the value of that expression is. Or here's something simpler. You know all of this is 180. You know this much of it is 47. So what would the value of this be? Whatever 180 minus 47 is. Okay, so you can do it either way. So I encourage you to go back, make sure you find the value for x, and then also the value for the missing angle. All right, now let's look at number 12 and 13. Same concept, different shape. So the magic number for the interior angles of a triangle is 180. So all of these added together give me 180. So set up your equation. I have 119 plus 29 plus n equals 180. Combine like terms and let's solve. 189, not 189, 119 plus 29. Let's do that math. 29. I have an 8 there. 4. So I have 148 plus n equals 180. And isolate for n. So we're going to minus 148 from both sides. And I see that the value of n equals, let's zoom in right here. 7. That's 2, 3. The value of n is 32. Perfect. All right, set it up here and see what you have. Now, I'm only giving one number here, but you guys know what this shape means. That means we have a 90-degree angle. All right, so 58 plus 90 plus k equals 180. Combine like terms and solve. All right, looking at the next page, I'm not going to dive all the way into each one of these because it's literally the same thing that we did before. They're just a little bit larger. So let's go through one together. So look at the first one. We have 4x minus 7 plus 3x plus 4, which is that one, plus 5x minus 9. All of that should equal what number? 180. All right, combine like terms. I see a 4x, 3x, 5x. 4 plus 3 plus 5, that's 7 plus 5 is 12. All right, now let's look at negative 7 plus 4 is negative 3, and then we minus 9. So negative 3 minus 9 is negative 12, and let's put minus 12 here. I just like how that looks. And then let's switch this to black. So I have 12x minus 12 equals 180. Let's isolate the variable, trying to get it by itself. We're left with 12x equals 192? Yep. And then let's just divide 192 by 12. Oh, let's slide that over. We have 1, 6, and nothing left over. So what does 16 actually represent? 16 is the value that we get when we solve for x. So if I ask you for the actual angles, we need to plug in 16 for our x here, 16 for x there, and then 16 for x here. So plug it in. Let's see what those values are. All right, and then number 18 through 21, I think you guys can understand how to draw it, but let me just show you one of them. It says find the supplement, which means I need to make 180. Draw the two angles as linear pairs. So the measure of angle ABC, let's do A. Let's put a midpoint at B, and then C is going to make 72. So if this is 90, if going straight up and down is 90, 72 would be less than that over here. So let's make a nice little slant coming back, and let's put C right here. So that's going to be 72, which means that this one right here is going to be 180 minus 72.